So hi there. This is actually a topic that I think is quite challenging, but um, is considered, something that people don't go back over. It's fractions and their parts and equivalents. And I think it's great to redo this. I redo this every now and again. So I'm going to make a video for that in case you want to go back and think about these fractions again. We're going to identify and use fraction representations for varying wholes, fractions of equal value in quantity. Okay. I think this is lacking a verb. We're going to, fractions of equal value in quantity, we're going to make fractions of equal value in quantity. Let's look at making sixths. Split each of these into 6 equal portions. Okay, so I see this whole rectangle, reminds me of a baking pan, and I'm going to do my best to try and split it into 6 equal pieces. I do feel like this one is a little smaller than that one. This is the joy of using marker when doing this. Okay, so really maybe like that. 6 equal portions. When I think about a circular shape, it's actually quite challenging for me, but I know that 6 is divisible by 2 and 3. So first I'm going to divide it into 2. And then it's easier for me, okay, here's a center, to split each one of these into 3. It's not exactly equal split, but so I'm going to go 1, 2, 3, and 4, 5, 6. Not perfect, but getting there. Like this one is a little bit smaller than that one. So it's almost like this line should have maybe gone like that. 6 equal pieces. Oh, when I see a group of stars, what am I thinking here? 1, 2, 3, 4. 4 by 1, 2, 3, 4, 5, 6. 6 equal portions. Well, since there's 6 columns, it could easily go vertically. But so I see 1, 2, 3, 4, 5, 6 groups of 4 stars. But a lot of my students actually end up splitting it almost like we did this rectangle, which is also totally fine. Each group has 4 sets of stars no matter what, if we split it into 6 equal portions. $33. Okay, so let's suppose I take $33 and maybe first, if I split that immediately by 6, okay, sure. You know what I'm going to do in my head? So secondary thought here. I didn't know how to divide by 6 right away, except now my brain is trying to process that. At first, my brain wanted to do 33 divided by 3 to get 11. And then it wanted to take that split it into 3 equal groups and split it into 2. And I mean, half of 10 is 5. And so this would be 5 1/2, which is $5.50. But then good news is that actually in this class, you get to use your calculator even. Let's see, or I suppose, so this would actually be $5.50 because this is $5.50. Yeah. So $5.50. Got it. And then we see something that is more like an inch marker or mile marker. So I'm going to first label it 0 to 1. And like I did with these others, I'm going to start with it being split into 2. So I'm going to start with half. Let's see. About right there is 1/2. And then from there, I would try splitting each of these into 3 equal pieces. So if I had this and I needed to split it into 3 equal pieces, got it. And if I had this, but I want you to like, I can hear myself even say that first I split it in half and then I take that and split it into 3 more. So, and that was because 6, right, is equal to 3 times 2. So I was thinking about it in terms of that to help me out, just because thirds and just seeing 6 equal pieces actually kind of challenging for me. All right. So what is a unit whole? Because I just feel like we saw 1, 2, 3, 4, 5 different unit wholes all split into 6 equal portions. So unit whole. A quantity or measurement that is identified as complete or in its entirety. Okay, so that's each one of these. This is an entire cake or whatever, entire rectangle. This is an entire length of 1. This is an entire $33. That's how much you're starting with. A fraction is a number that describes a quantity. That has been portioned. Along with how many portions? That are included in the amount. And I'm going to say, this is really a measurement of how much. How much is a measurement? So up here, we didn't make any fractions, but if I were to say 1/6, right, it describes a quantity that has been portioned. So if I think about 1/6 of these stars, so there's the quantity that has been portioned, along with how many portions? 1/6. So quantity. So this thing, it's been portioned into 6 equal parts. And how many parts? I want 1 part out of the 6. And that's our measure. A unit fraction is 1 portion of the whole. So when I said 1/6, that would be a unit of this. 2/6 would not be a unit fraction because it was not 1 portion of the 6. It was 2 instead of 1. So a couple of remarks. Fractions are written as A out of B, or A beats. Okay. I'm going to say it is really important to always label the whole or reference the whole. So 2/6 of what? 2/6 of $33 is different than 2/6 of an inch. The denominator, which is the B, and what I just wrote up here in the numerical representation of this quantity, the denominator is the number of objects. So the number of, I'm going to put of equal sized portions. Objects within the whole. I kind of find this language a little bit confusing. So when we're thinking about it in terms of portions, equal size portions, I prefer that, because if we're going to write 1/6 or 2/6, this is how many portions, as opposed to how many dollars or how many stars. That's the whole. And the fraction is how many portions. Now the numerator, which is the A in the numerical representation of the measurement, is the number of portions. Oops. Being considered. Do we want 1 out of 6 or do we want 2 out of 6 portions? Unit fraction. They always look like 1 portion. So 1 out of B portions. So unit fractions always look like this. Later on, you'll hear a thing about unit ratios where the 1 could be either place, but unit fraction always means 1 portion out of how many portions. Okay, let's take a random strip of paper, label it with a 0 on the left and a 1 on the right. Got it. Okay, here, it's not that great. I just took this random strip of paper. It actually has a line on it, so maybe I'll use that. This just comes from scratch paper. So label it. I can see the other sheet through this. So label it with a 0 on the left and a 1 on the right. Got it. Fold it in half. Okay, but I think I'm gonna make sure that my 1 is on the left and my 0 is on the right now. So there's my strip. I'm gonna fold it in half. Got it. Label your strip 0 halves, 1 half. Okay, so now this is equivalent to, okay, 0 out of 2. So 0 considered out of 2 equal parts. Here's where that fold happened. I don't know if you can see it. And this would be 1 out of 2 parts, 1 out of 2 equal parts from 0. And this would be 2 out of 2 equal parts. Okay, got it. Now split this into quarters. Got it, will do. So now I'm taking each half and folding it in half. Done. Okay, so now I have a couple of crimps in there. And it says label it with 0 out of 4, 1 out of 4, 2 out of 4, 3 out of 4, and 4 out of 4. Okay, so I'm going to start at 0. And I'm going to label this one. So 0 out of 4 pieces. I'm going to label this one, which was that first fold, 1 out of 4 lengths. This one would be 2 out of 4 lengths from 0. And this one would be 3 out of 4 lengths from 0. And this would be 4 out of 4 lengths from 0, giving us 1 unit away. 4 portions of this from 0 to 1 gives us all of those portions. So 1 whole unit away from 0. Rank the fractions 1/2 and 1/4 according to size. Okay, well, so 1/4 from 0 would be this distance versus 1/2, which starts at 0 and goes all the way to here. Yeah. So 1/2 is a further distance or a larger distance when compared to 1. And I think about this in terms of money too. This is distance, but money, like a quarter, is less than $1/2, which is 2 quarters actually. So there's the 2 quarters. Yeah. Show why here. Okay. So I definitely think that, so here, let me write this and try to use some of my inequalities too. I'm saying 1/2 is more than or greater than 1/4. And it's funny because this also points to the right. And if you look at the number line, 1/2 is to the right of 1/4, FYI, in terms of thinking about inequality symbols, because 2 quarters, which is the same as 1/2, is more than, oopsie, 1/4. Sorry about my mistake there. Yeah, so 2 out of 4 portions is more than 1 out of 4 portions. And they came from the same hole here. So because I was using this to do my judgment, then this worked. And then when I said it with money too, 2 quarters of in terms of money, like 50 cents is more than 25 cents, which is 1/4 of a dollar. So as long as we reference that whole, we kind of can rank these according to size. I mean, you have to be careful. You can't say that a $1/2 is more than a 1/4 mile. They can't come from different holes. That would be a hard comparison. I mean, they're just not even from the same unit hole. So, but when it came to this, 1/4 was a shorter length from 0 than 1/2. As a matter of fact, 1/4 was half of 1/2. So if you're going to split it into equal portions, 2 equal portions instead of 4 equal portions means each portion is bigger. So I'm going to actually write that. Yeah, when we split it into half, each length was bigger. So bigger portions. And when we had quarters, smaller portions. So the more you portion it up, the smaller each portion becomes. That makes sense. Shade from 0 to 3/4 and compare your 3/4 to another person who did this. Okay, so I'm going to go ahead and shade on mine here from 0 to 3/4 because I am me. But it says to another person, and there's not another person right now because I'm making a video. But I did this one time where mine was larger, and I'm going to compare these two, right? So the first time I did this, here's my first time doing this video. Mine went from 0 to 1. And now if you look at here, if I line up the zeros, so interestingly, my 3/4 almost lines up with the original me at 2/4. So, and why is that true? Well, this is why that's true. This length was bigger than the one I just drew. So my one whole length here was shorter than the from 0 to 1 that I had done previously. So not the other person, but me before, me in the past, had a much bigger hole. So if you ever see something like 3/4 being bigger than 3/4, it must mean that they did not come from the same hole. Let's write that down. Okay, so if I'm going to do a comparison, so quick sketch, half, quarter, quarter, 3/4. Okay, about half, right? 3/4. So this length versus this length, and they still say they're 3/4, but if 3 out of 4 is ever bigger than a different 3 out of 4, then they didn't come from the same hole. And that makes sense. 3/4 of an inch is much smaller than 3/4 of a mile. Yeah. How many ways are there to represent one whole? So when I think about representing one whole, we just did it in 1, 2, 3 different ways, based on how we portioned it. So it really depends on how it's being portioned, but there are infinitely many. Let's write that down. Infinitely many. So for instance, one whole could equal 2 out of 2 portions, or it might equal 3 out of 3 portions, or 4 out of 4, or 5 out of 5 portions. Yeah. So there are infinitely many ways to write down one whole, but you have to start with one whole and stick with that whole in order to know what you're talking about. Otherwise, we can't do real comparisons or real equivalencies. All right, so let's look at example 3, where we talk about equal portions again. What is wrong with the placement of 2/3 on this number line? Well, let me go back to the definition of fraction. A number that describes a quantity that has been portioned along with how many portions are included in the amount. Oh man, we need to add a word because there's something assumed here. Has been equally portioned. Portioned into equal portions, equally. So we really need all of those portions to be equal. So added word, because we go back to here and it says equal portions. Got it. So that is important. What is wrong with the placements of 2/3? So here's the thing. I think what's wrong with the placement of 2/3 is that in this, if we label this from 0 to 1, and then we think along with I don't know how this person was divvying it up. So for instance, were they thinking that this is one part, so that this is 1/3, this was a second part, so this is 2/3, and that this is the third part? Because it is split into 1, 2, 3 equal, or I'm sorry, 1, 2, 3 pieces, but they are not equal. So in this event, this is wrong because these pieces aren't equal in length. Now, when we think about this one, you know, and we think maybe they were guessing, maybe they put 1/2 here and they were saying they're guessing it here. Even so, when I look at this, I kind of see this. This looks approximately to be in the middle between 0 and 1. So I would likely give this a rank of 1 out of 2 pieces, or 1/2. And then this looks like it's halfway between a half and 1. So if that's true, if this one got cut in half, then this one also needed to get cut in half. And now they all kind of look like equal pieces. But if that's the case, now all of a sudden, this is not 2/3 anymore. This is 3 out of 4, maybe. So it's hard. You can't use a guess that it's between 1/2 and 1 and put it directly in the middle, because that would be 3/4, as this would be 1/4, 2/4, 3/4. So, 3 pieces somehow. To get it into 2/3. So I don't know, maybe now you have to cut every one of these into 3, or, oh, sorry about that. Maybe you would make it into 6ths, maybe you would make it into 12ths and then figure out where 2/3 is, but at this point. Okay, number 2, are each of the following rectangles representing quarters? Why or why not? Well, I think that you should really pause the video and do a guess for this, because most of my students disagree about that. But now I'm going to tell you. Okay, a couple of these feel more obvious than others. So this one is obviously not. I mean, just look at this piece compared to that piece. Yeah, those pieces are definitely different. The person who gets this piece is definitely thinking they have a smaller piece than the person that got this one. If they got this one, they're thinking, I got way more than that. But this one is an automatic yes. They all even look the same. They're just flipped. So this one, all of these pieces are absolutely equal. This one takes me a little bit of work because my mind wants to say, oh, there's purple on my nail. This one might be smaller than this one, or I can't tell, but I'm going to go ahead and I'm going to do more divisions to make them look like they are all equal in size. So let's suppose I add these cuts. Now they kind of all look equal. And this side, okay, so how many equal pieces are that now? If I'm looking just as it like this piece, right? Okay, hold on. So first of all, when it comes to these now, I see 1, 2, 3, 4, 5, 6, 7, 8 equal pieces, 8 equal triangles, and each one of these, so this one happens to be 2 out of 8. So 2 out of 8 versus this one. So there's one of those triangles and 2. So even this one is 2 out of 8. Yeah. So each one of these really is equal to 1/4, and they are equal in size. So this is a yes, because we chopped it into equal pieces, and then this side, that was 2 out of 2 of those triangles, and this one was also built out of 2 of those triangles, just differently built, differently arranged. So yep, all equal. So now how can I make these look equal? Well, I have a slash, I have a vertical. Let's suppose I do a vertical over here. Okay, now I have these tiny triangles. That's weird. I don't have any triangles over here. Let's suppose I do a cut like the other one. Okay, but now this piece is bigger than that. So let's do a diagonal cut the other way, maybe. And then now these pieces are bigger than that. Let's go across the middle. Now do we have equal pieces? Okay, so, and let's count up what's in each. So in this piece right here. Okay, so now I see in the whole thing, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 equal portions, 16 equal tiny triangles that look like this. 16 of those. And this one was 1, 2, 3, 4. 4 out of 16. So is this one. 1, 2, 3, 4. 4 out of 16. What about this one? 1, 2, 3, 4 out of 16. So they are all 4 out of 16, which is quarters. But in order to visualize this one and convince myself, I still needed to cut it into exactly equal triangles, smaller, 16 of them. Okay. Let's talk about example 4 of an inch. On the first line, label 1/2. Okay. 1, 2, 3, 4, 5, 6. There's 6. So half of that, I think, would be 3. 1, 2, 3 pieces. 1/2 from here to here. That is 1/2 of this. Got it. On the second line, label 3/6. 1, 6, 2, 6, 3/6. Okay. Got it. On the third line, label 2/4. What? This is chopped into 6. Ouch. Okay. In order to have a quarter, I mean, 6 is not divisible by 4. So I'm going to need to chop everything into 12ths. So if there's 6 equal pieces, because 12 is divisible by 4. So 12 divided by 4 equals 3. So because there's 6 pieces, I'm going to go like this. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I have 12 equal pieces. And now I can think about chopping this into quarters. It's a little easier for my, because I'll think of that. Each quarter has 3 of these little ticky marks. So each quarter is a distance of 3. So as a reference, I'm thinking, okay, so this one, 1, 2, 3, this is 1/4. 1, 2, 3, this is 1/2 or 2/4. Right there. And then I think another 3, 1, 2, 3, this is 3/4. Just to see those quarters jump out at us a little bit more. And then this would be 4/4. Okay, so there's 2/4. What do you notice? Well, here's what I notice. I notice that each one of these is the same length, and that's because they come from the same hole. So when I think about equivalent fractions, I'm going to actually write my answer to this right here. So what I notice is that 1/2 is equal to 3, 6 is equal to 2/4 of an inch, where my inch was the hole. So equivalent fractions have the same amount or measure, okay, but are represented differently. Because the hole was chopped differently. So because the hole, and maybe I'll write down same hole, was portioned differently. So this one was portioned into 2 equal portions. This was into 6 equal portions. This was into 4 equal portions, but they all ended up being the same amount of distance of an inch, but they all had to come from an inch for them to be equivalent. 1/2 of an inch is not equal to 3/6 of a mile. 1/2 of a dollar is not equal to 1/2 of an inch. So I wanted to specify here too that equivalent fractions, so things that are equal in amount or measure, is that not only do they have to have the same whole, so they all have the same whole, but it just got portioned differently. So this is a different representation of that, even though it ends up being the same amount. Okay, in the next video, you'll see more.